Today we'll be looking at graphing polynomial functions. So a polynomial function has the form of y equals an times x to the n plus an minus 1 times x to the n minus 1, all the way down to a1 times x to the power of 1 plus a naught. Okay, so a naught there would have been a constant. If there was a coefficient a1, then that would mean that we had an x term. Okay, then possibly an x squared term all the way up to x to the n. Okay, and n could have been 50 or 100 or 3. So really it's just a polynomial is going to be a bunch of powers of x added and subtracted with coefficients. And the powers on the x have to be whole numbers and they have to be positive for it to be a polynomial function. Now a power function, it only has one term. So it could still have a coefficient, but then it's just going to be x to the n. So for instance, y equals 3x cubed would be a power function. Next we have the degree of the polynomial. So the degree is the greatest exponent on the variable of any term in the polynomial. Okay, so when we have a fully expanded polynomial, you're just looking for the highest exponent of x, and that will be your degree. If it's not expanded, if it's something like this, then you have to sort of imagine what it would be when it was expanded. So to get the greatest power on x, we would have taken the x times the x times the x squared. And x times x times x squared is 4. So this function would be degree 4. Okay. Really, you're just looking at all the exponents on x that are going to be multiplied together. So there's a 1, and then another 1 here, but you're doing it twice, which adds up to 4. Using this same polynomial, if we were to find its roots, the roots of the function represent the x-intercepts. Okay, so in other words, it's where it would cross the x-axis. So if we set y equal to 0, we would be able to solve for the x-intercepts, and it's just going to be whatever makes each of the brackets, or each of the factors, 0. So in this case, the roots would be x equals -1, from the second bracket, -2, and from this third bracket, it would be a 3. Okay, and just because it's squared doesn't actually matter. It's just that that root would have appeared twice. So next we're going to look at some of the basic functions, or basic polynomials, that we already have studied. So in grade 9 we talked about linear functions a lot. Okay, those are functions of the form y equals mx plus b. The degree of a linear function or a line is degree 1. And the maximum number of roots. So if we think about drawing a line, whether it's positively sloped or negatively sloped, it can only ever cross the x-axis maximum once. Minimum number of roots, if we think about a horizontal line that does pass the vertical line test, so it is a function, it has 0 roots because it would never cross the x-axis. So there's a maximum of 1, which happens to be the degree of the function, and a minimum of 0. Next, if we think about the quadratic function, so a parabola, which we know has a standard form, a factored form, and a vertex form, the degree of a parabola is 2. And if we look at the number of possible roots, so most parabolas, whether they open up or down, have 2 roots. So 2 is a possibility. Okay, we can have a parabola that sits on the x-axis, so it only crosses it once. So 1 is a possibility. And then we can also have a parabola that starts either below or above the x-axis and only goes up or down. So we do also have the possibility of having no roots. Okay, so a quadratic function can have 0, 1, or 2 roots. So in other words, from 0 all the way up to the degree, which is the maximum. So next what we're going to look at is we're going to look at one page of cubic functions, and then we're going to look at one page of quartic functions. And here we're really just trying to see a pattern. So in the template version of the lesson, I've given you guys these already drawn out. Okay. You could have used Desmos to do it, but that's just a little bit time consuming. So if you flip a couple pages later in the note, you'll see that there's a section for cubic function conclusions and quartic function conclusions. So I want you guys to use that page of cubic functions to try and answer these questions. So what is the number of possible roots that you see on that page? What is the maximum number of turning points? And turning points are going to be max or min points. It's what it sounds like. It's where it turns around or it changes direction. Those are turning points. End behavior. Does the graph rise or fall to the left and to the right? Okay, what's happening with all those graphs? And then based on the sign of the leading coefficient, and leading coefficient is going to be the coefficient out front of our leading term, or our term with the highest degree. When it's positive, what does that mean for the end behavior? Okay, when it's negative, what does that mean for the end behavior? So take a few minutes, pause the video, and try and answer these questions for the cubic and the quartic functions. So looking at this, in terms of number of roots, we have some with 3 roots. In fact, we have quite a few with 3 roots. Down here, this one only has 2 roots, and this one right here only has 1 root. So we had 3, 2, or 1 as the possible roots. If we look at turning points, and if we count changes of direction, we've got 1, 2, so that's the maximum. And if we look at all of these, we'll see that the maximum in any of the graphs is 2. And that 2 just so happens to be 1 less than the degree. Next, the end behaviors. So if you look at the end behaviors, they end in opposite directions. Okay, so if one's starting from going down, the other one ends going up. If one starts up, the other one goes down. And what determines whether they're up or down is actually the sign of the leading coefficient. So if we go back and look at our cubic functions, this one has a positive leading coefficient, that one is positive, that one's positive. If we look at all of these 3 up here that have positive leading coefficients, you'll see it starts down in this quadrant and it ends up in the first quadrant. Okay, and that's true for all of the positive leading coefficient graphs. Our next line, it's all negative leading coefficients. And if we look at that, then we see that they always start up in quadrant 2 and they end down in quadrant 4. Okay, so that sign of that leading coefficient actually affects the end behaviors. So by just knowing that it's a cubic function with a positive leading coefficient, we know where it's going to start and where it's going to end. So for the positive leading coefficient, remember it started down in quadrant 3 and it ended up in quadrant 1. Okay, so we can write that with a little diagram, or we could say that the behaviors go from Q3 to Q1. And you might also see it written as falls to the left, rises to the right. And the negative is the opposite of that. That one starts in the second quadrant, ends in the fourth quadrant. So it goes from Q2 to Q4, and it rises to the left and falls to the right. So doing the exact same thing with quartic functions, the number of possible roots for a quartic function, there could be 0, 1, 2, 3, or 4. I didn't show you one with a 0 case, but a quartic, just like a parabola, it could just float up in space. Maximum number of turning points. So if you count it out, you'll see that the maximum number of turning points is 3, okay, which is 1 less than the degree. Okay, and that's always going to be true. The maximum number of turning points for a polynomial function is always going to be 1 less than the degree. What about the end behaviors? If you look at all the end behaviors of the quartic functions, you'll see that they go in the same direction. So they either both start and end up, or they both start and end down. So now we need to look and see what happens when there's a positive leading coefficient and a negative leading coefficient. Okay, so if we look at this first row, they all have positive leading coefficients. So the LC is positive. And we'll see that they all end facing upwards. When there's a negative leading coefficient, so when the LC is negative, we see that they start and end down. So let's write that in our table now. So the positive goes from Q2 to Q1, rising to the left and the right, and the negative goes from Q3 to Q4, and it falls to both the left and the right. Now you might be asking, how am I going to remember this? Well, a quartic function, that's an even degree. And in fact, all even degree functions are going to have the exact same end behaviors as a quartic. So a degree 6 function, a degree 8 function, degree 10 function, they're all going to have the same. And the most basic even degree function that we know is a degree 2 function, which is a quadratic. And we know a lot about quadratics. And if we think about it, a quadratic that has a positive a value, they do have this end behavior. Okay? And a quadratic that has a negative a value, it does open down, and it also has these end behaviors. So if you can just remember what happens to a positive parabola and a negative parabola, then you actually know the end behaviors for all the even functions, or even degree functions, I should say. Okay. Similarly with a cubic function. A cubic function is an odd degree. Okay. And if you think about the most basic odd degree function that we know, it's a line, right? Degree 1. If you think about a positively sloped line, it has these end behaviors. And if you think about a negatively sloped line, it also has these end behaviors. Okay, so once again, as soon as you remember what a positive and negative sloped line is, then you know the end behaviors of all odd degree functions. So next we're going to look at higher order roots, and you'll see that in the next video.